Hello friends, welcome back to my YouTube channel. This is part number 8 of my discussion on drawing, and in this I will be discussing a numerical example. This would be a fifth numerical example on the topic of drawing, and therefore I am calling this as numerical example number 5. So in this you will learn how to plot the typical rate of drawing curve. So if the experimental data that is generated through a typical drawing test is available with you, then we will learn how to use that experimental data to plot the typical rate of drawing curve. So let us begin the discussion. Okay, to begin with, let us look at the numerical statement. So the data recorded during the drawing test on a bed solid sample is given in the following table. So what is given to us at different time intervals, they have given us with the mass of wet sample. So here theta is time, which is measured in minutes, and MWS is the mass of wet solid, which is measured in kg. So we have different values. We have values of MWS at various time intervals. So this is the data that is given to us. So after every 10 minutes, they have recorded the weight of or they have recorded the mass of wet sample. So in this way, we have this different readings. Then the mass of bone dry solid is 3 kg, and the area that is available for drying it is 2 meters square. Then what are we supposed to do? First, we have to get the following data. We have to get moisture content on weight basis. So after every 10 minutes, we have to get moisture content on weight basis. Then we also have to get moisture content on dry basis. So after every 10 minutes, you also have to find moisture content on dry basis. And then we have to plot the drying curve first. And then after that, using the drying curve, we are supposed to plot the typical rate of drying curve. So we have mass of wet solids at various time intervals. So first we have to get moisture content on wet basis, and then moisture content on dry basis. Then we have to plot the drying curve, and we also have to plot the typical rate of drying curve. So this is the numerical statement. Let us move ahead. Okay, first let us list what is given to us. So a drying test is being carried on a sample of wet solid, and then experimental data is provided to us. MWS is provided as a function of theta. In this case, MWS is the mass of wet solid in kg, and theta is time in minutes. Then mass of the bone dry solid, it is given to us. We denote that by MDS, and it is 3 kg. Then area that is available for drying, it is also given to us. Well, let us see. We denote it by capital A. So capital A is 2 meters square. And what to find? First, we have to get moisture contents on weight basis after every 10 minutes. And then we have to get moisture contents on dry basis after every 10 minutes. Then what are we supposed to plot? First, we have to plot the drying curve, and then we have to plot the typical rate of drying curve. So this is the given information. Now let us move ahead. Let us understand the approach. So first, we will be finding out from the given experimental data. First, we will get moisture contents after every 10 minutes. And how are we going to get that? So MM, that is moisture content, mass of moisture is equal to mass of wet solid minus mass of bone dry solid. So MWS, you know, it is mass of wet solid, and MDS, it is mass of bone dry solid, and MM is mass of moisture. So this will give us moisture content in kgs. Then after that, we will find out moisture content on weight basis, and that we are going to get by using this equation. Small x is equal to mm upon MWS, that is mass of moisture divided by mass of wet solid. So this is moisture content on weight basis. and we will be getting this, we will be getting the values of x after every 10 minutes. Then we will be getting moisture contents on dry basis, and for that we are going to use this equation. Capital X is mm upon mds, that is mass of moisture divided by mass of bone dry solid, or you can also use this equation. Capital X is equal to small x divided by 1 minus small x. Then we will plot the drying curve. So for that, capital X, that is moisture content on dry basis, we will plot on the y-axis, whereas time, that is theta, we will plot on the x-axis. And then we will find fluxes of moisture removal, because we need those fluxes for plotting the typical rate of drying curve. For that, what we will do, once the drying curve is ready with us, we will select random points on the drying curve. And then for those points, we will note capital X, that is moisture content on dry basis, and then we will draw tangent at each of the selected point. So this discussion is based on my video lecture on the typical rate of drying curve. In the description section, I have given link to the entire playlist of my video lectures on dry. So after noting X for every selected point, we will be drawing tangent at each of the selected point, and then we will find slope of each tangent, and then from this slope we will find the fluxes of moisture removed, and for that we are going to use this formula. Capital N is equal to minus slope into mds upon A. So in this case, N is the flux of moisture removed. mds, you know, it is mass of bone dry solid. A is the area that is available for drying, and S is the slope of the tangent that you have drawn at the selected points. So in this way, we will get N values of N, different values of N, and finally once you have the values of N, we will plot the typical rate of drying curve. For that, capital N values we will be plotting on the y-axis, and capital X values we will be plotting on the x-axis. The resulting curve is nothing but the typical rate of drying curve, and that is what we are supposed to do in this numerical example. So I hope the approach for solving this numerical example, it is clear to you. If you have any doubts, you please mention them in the comment section. Let us move ahead. Now let us start solving this numerical example. So first, we have the experimental data that is given to us. We have values of MWS, that is mass of wet solids at various time intervals. I will just quickly note down all the given values. So this is given to us. So we have mass of wet solids after every 10 minutes. Now first we will find out moisture contents. And how are you going to get that? Moisture content, that is mass of moisture, is equal to mass of wet solid minus mass of bone dry solid. So mass of bone dry solid is 3 kg, and after every 10 minutes we have value for mass of wet solid. So we will subtract mass of bone dry solid from every reading that is given to us. From every mass of wet solid, or we will subtract mass of bone dry solid from mass of wet solid after every 10 minutes, and that will give us moisture contents after every 10 minutes. So if I use this, so I will be getting that is mass of moisture. So for first, at t is equal to 0, mass of wet solid is 5. So 5 minus 3 will give us mass of moisture, that is So it is 2. Then 4 minus 4.60 minus 3 is 1.6. 4.30 is 1 point. Now 4.30 minus 3 is 1.3. 4.05 minus 3 is 1.05. So in this way, we will get moisture contents after every 10 minutes. So 3.60 minus 3 is 3.6. 3.50 minus 3 is 0.5. 3.42 minus 3 is 0.42. 3.35 minus 3 is 0.35. 3.28 minus 3 is 0.28. 3.24 minus 3 is 0.24. 3.20 minus 3 is 0.20. So in this way, we get moisture contents in kg after every 10 minutes. Then we will get moisture content on weight basis, that is small x, and we are going to get it by using this equation, mass of moisture divided by mass of wet solid. So simply it will be mm upon mws. So for the first at t is equal to 0, it will be 2 upon 5, that is 0.4. Then 1.6 divided by 4.6, it is 0.348. 1.3 divided by 4.30, it is 0.302. Then 1.05 divided by 4.05, it is 0.259. 0.9 divided by 3.90, it is 0.31. Then 0.75 divided by 3.75, it is 0.2. 0.6 divided by 3.60, it is 0.167. 0.5 divided by 3.50, it is 0.143. 0.42 divided by 3.42, it is 0.123. Then 0.35 divided by 3.35, it is 0.104. Then 0.28 divided by 3.28, it is 0.085. Then 0.24 divided by 3.24, it is 0.074. And the last one is 0.2 divided by 3.2, that is 0.063. So in this way, we get moisture content on weight basis after every 10 minutes. Then let us get moisture content on dry basis after every 10 minutes. So that is capital X, which you can obtain as mass of moisture divided by mass of cold dry solid. So let us do that, or you can also get it by this formula, as I said. So capital X is small x divided by 1 minus small x. So you can either use this formula or this formula. You are going to get capital X, which is moisture content on dry basis. So let us get different moisture contents on dry basis. So first it is 2 divided by 3. So it is 0.687. Then 1.6 divided by 3, it is 0.533. Then 1.3 divided by 3, it is 0.433. Then 1.05 divided by 3, it is 0.350. Then 0.9 divided by 3, it is 0.3. Then 0.75 divided by 3, it is 0.250. Then 0.6 divided by 3, it is 0.2. Then 0.5 divided by 3, it is 0.167. Then 0.42 divided by 3, it is 0.140. 0.35 divided by 3, it is 0.117. 0.28 divided by 3, it is 0.093. 0.24 divided by 3, it is 0.080. And last one is 0.20 divided by 3, it is 0.067. So in this way, we get moisture contents on dry basis after every 10 minutes. So over here we have got moisture contents, we have got moisture contents on wet basis, and we have also got moisture contents on dry basis. So I hope these calculations are clear to you. If you have any doubt, you please mention that in the comment section. Let us go ahead. Okay, so let us plot the drying curve. So for that, on the x-axis or on the y-axis, we will be plotting capital X, that is moisture content on dry basis, and the scale that I have chosen, you can see over here. So 1 centimeter is 0.1, and on the x-axis we are going to plot theta, that is time, and the scale is 1 centimeter is 10 minutes. So if you plot the data that we have obtained, that is moisture content on dry basis versus time, you'll be getting the drying curve. So after you plot the data that was generated previously, you'll be getting this drying curve. So this is the drying curve that is obtained by plotting the experimental data, by plotting the data of moisture content on dry basis versus time. Then as we understood, and while understanding the approach, we will first select random points on the curve, on the drying curve. So you can see I'm selecting this random points. This red cross represent the points the random points that I have selected on the drawing curve. So these are the random points that I have selected on the drawing curve. So I have selected 1, 2, 3, 4, 5, 6, 7, 8 and 9 the random points. You can select more than 9, no problem. But at least 8 to 10 points you have to select, because that will be that we will need for plotting the typical rate of drawing curve. Okay, so I have selected 9 random points, and you can see the points that I have selected covers the entire curve, and that is how you have to select the random points. So I will note down the value of x for each of the selected point. So for this point, value of x is 0.62. Then for this point, the value of x is 0.5. Then for this point, the value of x is 0.45. And then for this point, the value of x is 0.38. For this point, the value of x is 0.28. Then for this point, the value of x is 0.18. For this point, the value of x is 0.13. For this point, the value of x is 0.09. And finally, for this point, the value of x is 0.07. So in this way, I have measured, or I have noted down the values of x for the points, for the random points that I have selected on the drawing curve. Then we will draw tangent at each of the point and then find out the slope of those tangents. So first I will draw a tangent over here. Now let us find the slope of this tangent, and then we will note the slope over here. So on this small tangent that I have drawn at this point, I will select 2 points. One point is the point that the random point that I have selected, and for that point the coordinates are 3, 3 and 0.62. And then I will choose any other point on the line so that I can find out the slope of that line. So the point that I have selected is 6 and 0.58. So this is the point that I have selected, 6 and 0.58. So now I have 2 points on the tangent, and then I can find out the slope. So slope is 0.62 minus 0.58 divided by 3 minus 6. So this line has a negative slope, and you can see we get a negative value. So slope of this tangent is minus 0.013. So I will note over here. So slope is minus 0.013. Now next I will draw a tangent at this point. So I will draw a tangent at this point. Okay, so as I said, next I will draw tangent at this point. So I have drawn this tangent. So again we have to find the slope of this tangent. So for that I need 2 points on that tangent. So I have these 2 points. One is the random point that I have selected, and it has coordinates of 13 and 0.5. The other point that I have selected on this tangent is having coordinates of 11 and 0.52. 11 and 0.52. So over here I have selected. So now I can easily find out the slope of this tangent. So slope is 0.5 minus 0.52 divided by 13 minus 11. So slope comes out to be minus 0.01, and I will note down that slope over here. So at x is equal to 0.5, the slope of the tangent is minus 0.01. Next I will draw tangent at the next point, at this point. So let us. Okay, so now I will draw the tangent at the next point. This is the point. So I have drawn this tangent, you can see. So again we will note 2 points on that tangent so that we can find slope of the tangent. So one point is the random point itself. It has coordinates of 18, 0.45. So this is the point, and the other point that I have selected is 21 and 0.42. So over here is the point. Okay, so once you have 2 points we can find the slope. So slope is minus 445 minus 42 divided by 18 minus 21. So that gives us slope as minus 0.01. So at x is equal to 0.45, slope is minus 0.01. Next, I will draw tangent at the next point over here at this point. So let us do that. Okay, so now I will draw tangent at this point. So I have drawn this. Again, we will select 2 points on it. So one point is the random point itself, that is 26.38, and the other point is 28.36. So over here I have selected the other point on the tangent. So with these 2 points we can find the slope. So slope is 0.38 minus 0.36 divided by 26 minus 28. That gives us slope as minus 0.01. So at x is equal to 0.38, slope is again minus 0.01. Now next, let us draw the tangent at this point. So I have drawn the tangent at this point. Let us note down 2 points on it. One point is 44.28, that is this point, and the other point is 47.26 over here. 47.26. So slope will be 0.28 minus 0.26 divided by 44 minus 47. So that gives us slope as minus 0.0067. So at x is equal to 0.28, slope is minus 0.0067. 0.0067. Now let us draw tangent at this point. So I have drawn tangent at this point. The 2 points on this tangent are 65.5, 0.18, and the other point is 68, 0.17. You can choose any 2 points on this tangent, the tangent that you have drawn. So therefore, in this case, slope is 0.18 minus 0.17, 0.18 minus 0.17 divided by 65.5 minus 68, and that gives us slope as minus 0.004. So at x is equal to 0.18, slope is minus 0.004. Next, we will draw tangent at this point. So this is the tangent. We will again note down 2 points on it. One point has coordinates of 85 and 0.13, and the other point on this tangent is 88, 0.12. These are the points that I have selected. Then slope will be minus 0.13 minus 0.12 divided by 85 minus 88. That gives us slope as minus 0.033. So at x is equal to 0.3, slope is minus 0.0033. Then let us draw tangent at this. So this is the tangent. So any 2 points on the tangent, I have selected this. It has coordinates of 103 and 0.09, and the other point is having coordinates of 108 and 0.08. So these are the points on this tangent, and slope will be 0.09 minus 0.08 divided by 103 minus 108. So that gives us slope as minus 0.002. So slope at x is equal to 0.09, it is minus 0.002. And finally, we will draw tangent at the last point that we have selected. So this is the tangent that I have drawn. Any 2 points, I have selected these points. One is having coordinates of 117 and 0.07, and the other is having coordinates of 120 and 0.065. So therefore, slope will be 0.07 minus 0.065 divided by 117 minus 120. So that gives the slope as minus 0.0017. So at x is equal to 0.07, slope of the tangent is minus 0.0017. So in this way, we have drawn tangent at all the points that we had selected. We have found out slope of all those tangents, and now we have this data. So this is the data that we have obtained from the drawing curve, and now we are going to use this data to plot the typical rate of drawing curve. So I hope the calculations are clear to you. How random points are to be selected, that is clear to you. How tangents are to be drawn at those selected points it is clear to you. And then how to find slope of each of the tangent, that is also clear to you. If you have any doubt, you please mention that in the comment section. Let us move ahead. Now let us plot the typical rate of drying curve. And for that we first need to find out N, the flux of moisture removal. So we have recorded all x values, different x values at those random points. Then we have found out slope of the tangents that were drawn at those random points, and now we are going to find out N for each of the points. So first I will list all the x values, and then we have got the slopes of tangents at these points. Now let us find out N, which is moisture flux. So it is given by this formula. N is equal to minus slope into mds upon A. mds, this is mass of bone dry solid. It is given to us, it is 3 kg. Area that is available for drying, it is given to us, it is 2 meters square. So let us use this formula for getting N for each of the point. So in the first case, N will be 0.0195, then it will be 0.015, then it will be 0.015, then again it will be 0.015. So you can see the rate is constant. So it seems that this is the constant rate period. Then we have N is 0.01005, then it is 0.006, then it is 0.00495, then it is 0.003, and finally it is 0.00255. So by using this equation or this formula, we have got different values of N. Now the only job left is we have to plot N versus X, and the resulting curve will be nothing but the typical rate of drying curve. So next we will plot the typical rate of drying curve. Let us move ahead. So for getting the typical rate of drying curve, on the y-axis we are going to plot M, which we just calculated, and on the x-axis we are going to plot capital X. So when you plot the data, you will be getting the typical rate of drying curves. So this is the typical rate of drying curve that is obtained in this case, and you can easily identify the different sections on this curve. So first section is this section, then you have this section, then you have this section, and finally you have this section. So this is section number 1, this is section number 2. I'm calling it as section number 2. I will call this as section number 3, and finally I will call this as section number 4. Now you can easily tell in this case section 1 is nothing but the initial adjustment period. Then section 2, where the rate is constant, you can easily tell it is the constant rate period. And section 3, where there is linear fall in N, and you know that is the first falling rate period. And finally you have the second falling rate period, which is represented by section 4. So section 4 in this case, it represents the second falling rate period. So in this way, we have plotted the typical rate of drying curve, and we have identified all the 4 sections for the typical rate of drying curve. We have initial adjustment period, we have constant rate period, we have first falling rate period, and finally you have the second falling rate period. So that is what we were supposed to do in this case. We were supposed to plot the typical rate of drying curve, and then we have plotted the typical rate of drying curve. So with this, I will end my discussion for this numerical example. And this, I hope you have learned how to use the drying test data to first plot the drying curve, and then how to use the drying curve to plot the typical rate of drying curve. So I hope you have followed what I have done in this numerical example. If you have any doubt, you please mention those doubts in the comment section. For this video lecture, I will stop. In my next video lecture, I will discuss another numerical that is based on estimation of time for batch drying. So thanks for watching this video lecture. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you'll be notified as soon as I upload any new video on my YouTube channel. Hope to see you soon in my next video lecture. Till then, have a nice day. Bye bye.